Hello everyone, my name's Logan and welcome back to the lecture hall. For today's video, we are covering new functions from old ones. So what are we even saying? Well, so we're going to figure out how to shift our curve, how to stretch our curve, how to shrink our curve, and just do all the fun things to it. So let's say we have this curve f of x. What if we then decided I'm gonna add a constant to the end of that? So that would bring us to our orange line, f of x plus c. That is going to shift our graph up c units. Same thing in reverse with minus c. If we did f of x minus c, that would shift our original curve down down c units. And so now let's say we have f of x plus c inside the parentheses, including that constant inside our function. Well, that is going to move our original function to the left c units. And now if we had f of x minus c inside of the parentheses, that would shift our function to the right c units. Now that we've done horizontal and vertical shifts, we can move to stretching and shrinking. So let's just have our curve f of x. This is our normal curve, or our standard curve that we're starting with. Let's say we multiplied that by a factor of c. Well, this orange curve would become c times f of x. And so that's just multiplying every output value by a factor of c. So now, and so that's going to stretch it, make it bigger. Now what if instead we multiplied by 1 over c? Well, that will shrink our function to this purple line, and it'll, instead of stretching it, it'll shrink it. Now, instead, we had our normal curve f of x. What if we did negative f of x? Well, that would reflect it over the x-axis, and it would be the same curve. And when I say same curve, it wouldn't be stretched, it wouldn't be shrunk, but it would just be all negative. Now, last one, what if we had f of negative x where the negative x is inside the parentheses? Well, that would reflect our curve across our y-axis, and it would be the same exact curve, it would just be pointing in the opposite direction, and so on. So, these are all of our horizontal shifts, vertical shifts, shrinking, reflecting, all that good stuff. The final thing I wanted to cover in today's video are composite functions, or a composition of functions. So what is that? Let's look at our definition. So given two functions, f and g, the composite function, or the composition of the two functions, f of g, is defined by f, this little circle O thing, which is pronounced f of g of x, and essentially what is that? Well, it's just the function g of x nested inside of f of x. So let's see how that works with our fancy little picture. Essentially what you do is you put x into the function g, you would get a g of x, and then put that directly into your function f, and you would get an f of g of x. Or we could just have our composition of functions pre-made into a separate equation and just plug it into f of g of x, and we would still get f of g of x. So what is an example of a composition of functions? Let's do two. Well, we could have the square root of x plus 3, and that could be y equals that. Well, what are our two functions? Well, f of x will be the square root of x, and then g of x would be x plus 3. Sweet. So then let's do another one. Let's say y equals sine of 14x to the 5th. Well, what is our inside function and what is our outside function? Inside function is going to be our g of x. Outside function, our f of x. So f of x will be sine of x, and then g of x will be 14x to the 5th. So that's pretty much everything I wanted to cover in today's video. Another real quick one just to get us to the calculus. Thanks for watching. As always, my name's Logan, and have a great day.